Let's look at the sets data type in Python. Uh, the set is a data type in which we can store elements or data of any type as long as they are not repetitive in nature. Fine. So let's see how to create that. Let us say I create a variable called as st1 and I say it's equal to open a flower bracket. I can assign any elements here as part of this data. I can make it a string or anything else. Right, and if I look at the type of this data now, whatever I created using a flower bracket, it's a set. Now, the unique thing about set is you can't have a repetition of any data. So if I create a set 2 where I create, okay, now in this list of items you can see I've repeated 2. I've repeated 2 multiple times here. I've repeated 1, I've repeated 3. And when I create this set, it does not throw an error, but if you look into the data, you will see all the elements inside this have appeared only once. 1, 2, 3, 4, 5, 6. Even though 1 was repeated, 2 was repeated, 3 was repeated, even though things were repeated, they appeared only once. So in a set, you can't have a repetition of data. Data is present only, every data element is present only once. Right? Uh, the set is not accessible by index, so it's not an ordered way of storing data. So I can't say set of 0 is something. This has no meaning because set is not subscriptable. You can't look into a set like this. If you want to go over a set, you'll have to loop over it. So I can say for item in set 2 and then say print each element. This will take one item from the set and print them as a normal iteration. Alright, so the primary benefit of a set is avoiding duplication. So I can have a set of elements and ensure that none of them are duplicated by each other. And it supports various other set related methods. So set, as you know, is a mathematical concept. So all the mathematical set related operations can be done on the Python set also. So for example, I can, let's say I want to add an element. Now I have set 2. I want to add the element 7 to it. So I can do set 2 dot add. I can say add the element 7 and I can look at the value. The value 7 has got added into it. Okay. If you want to delete all the elements of a set, let's say I create a set 3, I create the set 3. If I look at set 3 now, it has the elements 1, 2, 3. I can remove all the elements from this by saying clear. If you look at set 3 now, it has nothing in it. All the elements got deleted. Fine. So clear is to clear all the elements from it. You can create a copy of the set by using the copy method similar to what we have seen in the past. So if I want to create a set 4, I can say set 2 dot copy and set 4 will be exactly same as set 2, only difference being that it is not a reference of it. Set 2 and set 4 are different sets now. So if you do a direct assignment, it becomes just same set being referred by two different variable names, but copy creates a fresh copy in a different set altogether. Fine. Now, if you want to find the difference between two sets, that is, if I, for example, now I have set 2 here and I create a set 3 which has elements, let's say 1, 4, and 6. And if I say set 2 dot difference with set 3. So you can see set 2 is this. Okay, set 3 is this. I'm asking for it to find the difference of both of them. So it will basically look at set 2, look at set 3, and whatever element is present in set 3, those will be removed from set 2. Okay, which is common to both. So 1 is present here, 1 is present here, that is removed. 4 is present here, 4 is present, that is removed. 6 is present here, 6 is present, that is removed. Okay. Now if I create a set 3 which has some element which is not present in it, let's say I create 1, 4, 8. and then ask it to give me the difference, you can see the items of set 3 will not become a part of this result on it. It is only taking the set 2 and finding the difference of elements in set 2 with respect to set 3. Okay, that means if an item is present in set 3, that is removed when you do the difference. But if item is present in set 3 and not present in set 2, that does not really matter to the final result. There's a small variation of this called difference and update, which will here the result is being returned as a new set. But if you want to change the set 2 itself, I can do the same difference and I say update. So now set 2 itself gets modified. Right? In only difference, the difference was being calculated and was returned as a new set. So you could assign it to different set variable and use it for some other purpose. In difference and update, difference is being calculated and the difference is being updated into set 2 itself. Right? So slight variation. Where you want to update the existing set itself, you can use the difference update. Similar to difference, you also have intersection, that is normal set intersection you have seen in the past. So this is my set 2 now. If I look at set 3, okay, there's no intersection here. Let me take some other value. Okay, I've taken a new set now so that I can have some intersection. Set 2 dot intersection of with set 3. It will return elements which are occurring in both. Right, so set 2 and set 3 both have 2 and 5, so that is, you know what intersection in sets are, right? So that's what we're trying to get out of the intersection method, right? So what else is there in as methods? You can similarly, just like difference update, you have an intersection update also. So if you want to directly update the set instead of just finding the intersection, you can use intersection update. You can find out if a set is a disjoint set or not. So if I say is set 2 is disjoint from set 3, if you ask, it will say it's false because set 2 you can see has 2357, set 3 has 8125, and these are not disjoint sets, right? So it gives me false. Let me create a set 4 which is a subset of it, of let's say I say only 2 comma 3, and I ask is set 4 is subset of set 2, sorry, brackets are wrong. It'll say true because set 4 has 2 and 3 and set 2 has also has 2 3 along with other elements. So set 4 is the subset of set 2. If you ask the other way around, is it is set 2, is it superset of set 4? That will also be true because every element present in set 4 is present in set 2. Right? So those are again set related operations mathematically. This we're doing in a programming format here. And if you want to remove an element, a random element from a set, you can simply say pop. We don't know which element is going to be removed. Any random element could be removed from the set. Right? If you want to remove a specific element, I can say remove and give the element value. So that will be removed from the set. Right? And you have something called symmetric difference. Symmetric difference is like an XOR. So if I have set 2 now and I take a set 3, which has, let's say, 4 and 8, 4, 5 and 8, let's say, right? So if I do a symmetric difference with set 3, this is like XOR, right? If the element is present in only one of the two lists, only those will be picked. So if you look at it, 3 is present in set 2, not in set 3. 4 is present in set 3, not in set 2. 5 is present in both, so that is not picked. 6 and 8 are again unique. So it'll only pick up elements which are present in only one of the lists but not in both the lists. Fine. And a slight variation of it is systemic symmetric difference update, where if you want to update the set 2 itself with the result, you can use underscore difference underscore update. Fine. Union is like a set union. With respect to, I can do a set 2 union with set 3. It will make a union of both the items, and whatever is repeated is going to be used only once. So 3 pi 6 and 4 pi 8 both are combined together. 5 being repeated is being only used once. If you want to update this into set 2 itself, I can, instead of doing union, you can do update. Set 2 itself gets modified with the union of both elements. So that's the basis of sets. Application wise, it has huge number of applications. We can try a few basic programs on sets to understand it better. Right. Thank you.